A warm welcome to all of you. On behalf of MIDAS GTS NX, I welcome you all to this webinar on tunneling with GTS NX session 2. As described today in this session, basically I will be taking a problem and will complete it right from the basic modeling to the complete analysis. We'll look upon on each option in detail. So basically making you familiar with the workflow and the interface of GTS NX. So that will be the purpose of today's webinar. So first of all, talking about the problem, what exactly we'll be doing in today's problem and a brief idea of the same. So first of all, we are going to consider a 90-degree tunnel intersection in our modeling basically today. We'll be considering a simple homogeneous soil to keep things simple, and then we will consider construction stage analysis. The definition will look like the animation, which I'm just going to show you. It will look something like this. Okay, so we have a main tunnel, and then we have the side tunnel. So we'll complete with the presentation the excavation, I'm sorry, of the main tunnel, and then we will move on to the excavation of the side tunnel. Okay, so today this is the problem which we are going to take, and we'll see in detail how exactly we can solve such kind of problems in GTS NX. What will be the general workflow, how exactly you can model it, everything in the software itself. Okay, so brief introduction to the problem. Again, you have a main tunnel, you have a side tunnel. We're considering a 90-degree intersection with both of them. The first one will be excavated first as the construction stage definition is concerned, and then the side tunnel. Okay, so let us move on to the program now. Fine, so I'm opening a new file new. So whenever you want to start with the program, the initial setting, the initial basic setting of what the problem type is, whether it's a 2D, 3D or isometric, what the unit systems you are going to take will be asked at the initial. So the model type cannot be switched over while you work onto the present on the model. For example, if you started with 3D, the model type will be 3D all throughout. Okay, but the unit system can be anytime changed, and so are the initial parameters. Okay, so as of now, we have model type as 3D, the unit system as kilonewton, meter, and second, and initial parameters as default. Say okay, fine. So talking about the MIDAS GTS NX interface, the top bar we called it as main toolbar, which is divided in the workflow of any problem. You have to start from left, geometry, then mesh, and the type of analysis which you want to do, then the analysis case, and finally the results. The left hand side, which we call as the worktree window, is divided into 4 parts: model, analysis, results, and properties. Many times if you happen to close any of this option, it becomes very important. It becomes very important that you take care of the same while you deal with it. For example, I just closed model right now. Once you get familiar, you should always note that from tools and show hide button, you can always control the interface, what all you want to see while working in the interface. So you can check it from here. Okay, so that's a very important part, a small part but very important part. At times people cannot find this option, so from tools you can control the view options of your interface. Okay, so everything you create, so it's divided in model. So till the meshing, whatever geometry modeling, whatever commands, whatever material property or whatever mesh that you create goes in the model tab. After that, whatever boundary condition, load condition, analysis case, construction stage, definition, everything comes in the analysis. Finally, you have the results where you can see or view the results, Properties are basically when you want to check the property of any selected item, you can go to properties and check for that. Okay, so even if you want to control, I will show you that the displacement contour, the deformed shape, what there are some default uh, amplification given. For example, deformed shape, if it's too amplified for you, you can go there and change the values. Fine. The main, you have the work tree window, and at the bottom you have the output window. Now, as we move on, I will highlight on various important factors. But first of all, let me talk about the work plane. Okay. Now, as you can see on the right-hand side corner of the working window, that the program shows you the GCS, or the global coordinate system, which is X, Y and Z in the vertical direction. Okay, then you have the work plane where you can see the grid. Okay, it's very important to understand that any 2D command which you will be creating will go in this work plane. Okay, so at times when you want to change the work plane, so you go to model. For now, the work plane is XZ. Now XZ, it is as per the global coordinate system. If I want to make it XY, so you can change the work plane. Okay, so if you double click, you can see that the work plane is changed. Okay, so it's very important that whatever 2D geometric commands from the top, whether it's rectangle, whether it's a circle, all these are 2D, right? So it will be created in that particular work plane, and we should make sure that we are working in the correct work plane while you use that geometric command. Okay, so to start with our modeling, let's say XZ. Fine. So first of all, let us create a rectangle, which will be our soil model. So my work plane right now is XZ, so good enough for me. So the rectangle will be created in that particular work plane, say 0, 0, and the relative dx dy. So there are two methods of inputting it. Absolute, so absolute will be as per the with respect to origin, and relative means with respect to your first point. Since we are dealing with 0, 0 now, so both will be same. So please make sure you input correct, you select the correct method while you input the coordinates. So 40, 40. I'm closing it. This is an isometric view. Okay, so many times this view helps you adjust the model which you created in your working environment. So you just click it so that it gives you a look of what you have created. Okay, now let us create our main tunnel. So I will use the tunnel sections already available. Okay, so let's suppose we have a 4 by 4. So I'm taking a symmetric one. Okay, and let us move it to the center, say 20, 20. Fine. So this is our main tunnel. Okay, I'm not considering any reinforcement to keep things simple. Okay, now let us extrude it to desired direction. Okay, next command we are using is extrude. So select the target object, you make it basic, select the wire, which is the outer rectangle, select the direction, let the length be 40 meters. You can name it. Always naming helps to differentiate the solid which you have created, say main ground. So it becomes helpful when you hide and unhide things. Okay, so you will be able to name the geometry set, say apply. Select the target object, make it basic. Once again selected the main tunnel 40, and I'm naming the solid as main tunnel. Say preview it, say OK. Fine. Now I'm just hiding the main ground. Okay. Now I just want to divide my main tunnel solids in the desired excavation sequence. Okay. Now the thing which we need to do the divide the solid is we can use the divide command. But for divide command we need a proper dividing surface at desired location. Okay. So what we'll be doing is we say rectangle make face. Okay, so I'm going to the front view, and you can create any rectangle moving your cursor such that it encloses your figure. Please remember that still the work plane is XZ, so you are able to create it at that particular profile. Had it been in for example, when we'll be dealing the side surface, we need to move the work plane to the desired. Okay, for now it's simple because we have selected the correct work plane. So next we can translate it. Select the target object. So face selected, select the direction. You can directly select it, make a copy, let's say 2 meters, number of times being 19. Preview it and say OK. Fine. Now we can say solid divide. Select the target solid. I will save it. Okay. Select the target solid. Select the tool surface. I make it by intersection. Select by intersection. So there are different modes. You have select by polygon, select by circle, select by intersection, select single. Okay. So by intersect, what I'm trying to do is I'll just intersect these faces. Select it. Delete the original. This means that the original solid which you have created, which is one intact solid, will be deleted, and the new solids of course will be kept. And delete the tool means all these faces will be deleted. Okay, so the name goes main tunnel only, and just say OK. So you have the solids created. Good enough till now. Now I will just check on the main ground. So still both the solids are independent. I just perform the auto connect. So Boolean operation. Select all and just say OK. So if I hide the main tunnel solids, you can see that it has been cut out of the main ground. Okay, till now very simple. Just what we used is we used the rectangle command. We created a tunnel section, extruded it. Then we used the solid command to divide the main tunnel solids as per our construction stage definition. I'm taking here the length of one excavation sequence as 2 meters. Now we have to come to our side tunnel, right? Now first thing is, to create it, I need to move my work plane at a particular location. Or for example, my side tunnel starts from the right hand face of my solid, correct? So I cannot use any of the default work plane. I cannot use XY, XZ, XZ, okay? Because even if I use YZ, it will be helpful for me, but I have to translate it again. So I can start from this face, making the work plane as YZ. But let me show you another option. Let's say move work plane. I'm using 3 points. So I'm making this point as my origin so that I can input the coordinates easily. This point as the x-axis reference and the top as y reference. Now just when you say OK, you can see that the work plane has been moved to that particular point, okay, and that particular axis. Now I can use rectangle. Please note that now it will be created in that particular work plane, say 2, 2, and once again 20, 20. If I can just preview it, you can see that it is coming at the correct work plane where I'm expecting it to. And I'm just naming it as side tunnel and say OK. Fine, good enough till now. Now I'm just hiding this solid. I'm just making it select by single and say height. Fine, even you can just go to the workspace window and hide it from there. Now let us extrude our side tunnels. Extrude. Select the target object. I'm making it basic. Select the direction. I'm giving some length, let's say 20 meters. It's going in the other direction. Preview helps you to make sure that which direction it's going. So reverse the direction, preview, and say OK. Now one problem is that there is some portion, even if I give an accurate length, since this is a curved face, we have to perform the Boolean cut operation to cut the solids out of the main tunnel, because first we'll be completing the main excavation tunnel. So geometry, now we can use the Boolean operation, say cut. Now select the target object. So I'm selecting this. Select the tool object. this. If you can, we don't want to delete the tool, which is our one of our excavation solid. So I will select another tool. Okay. So preview it and okay. Fine. So if I just hide the main tunnel now, so it's as simple as that. It's able to take on that curvature as well. Okay. So just I extrude it and simply perform the cut operation to divide the solid of our side tunnel. Fine. Now we need to divide it as per our excavation sequence. I'm using a rectangle again. Now make sure that this is my work plane. So I'm just saying make face and creating one rectangle such that it encloses the side tunnel. Okay. Now let's say translate. Select the target object, select it, select the direction, copy, let's say distance of 2 meters and number of times being 8. Preview it. It's going in other direction, so I'll just put -2, preview. So you will understand the importance of preview, that whenever you're not sure of which direction it is going. So I'm just making it 7 so that we don't have a very small excavation sequence at the last. Okay. Just say okay. Fine. Once again the same commands. So solid divide, select the target solid, select the tool surface. You can do it manually, or see, unhiding or hiding things helps you very much, and so is the naming. I just say main tunnel gets hidden. Now I can go to the right side view. Once again select by intersection, and I can directly select this faces, preview it and just say okay. Name is side tunnel again. Fine, good enough. So if you see that we are just using the basic commands. So if I just summarize the commands which we use extrude most of the times to create the main solid. Then moving the work plane is very important to make sure that the 2D profile is at correct location, and then you can simply extrude it. Then we use the command translate, especially in this case to move our cutting plane, what I can say, the dividing tool, dividing surface tool, and then we use the command solid divide. Okay, so with the help of that we are able to create this solid. Once again I will perform the auto connect with all the solids so that the side tunnel as well is cut out of the main tunnel. Okay, so this is our modeling. So hope you got an idea of how to model. Okay, and MIDAS GTS NX. Now, after the modeling is done and you make sure that you have performed the auto connect, you go to mesh, you go to material. Now let us define an isotropic more column material. So this will be our soil. Using the default parameters, just increasing the E modulus, okay, then porous, and then you have the nonlinear. Just say apply. And let's suppose I have elastic concrete material for my shotcrete. I'm giving some value at 0.2 E7, Poisson's ratio is 0.2, and finally you have the unit weight, making it concrete. Say okay. Fine. Now let us go and define the properties. So if you see, we have mostly everything as solid elements today. All the excavation and the main ground, so soil, and we'll be defining shotcrete as mentioned in the basic problem. So I'm taking it the thickness as 0.3 and just naming it as shotcrete, let's say, and say okay, close it. Fine. Now we'll start meshing it. First of all, I'll just hide the main ground. Okay, let's suppose maybe the side tunnel. So you can see the importance of naming. The hiding, unhiding things becomes very effective. Now let us start with meshing of the main tunnel. So mesh, 3D mesh, select the objects. Now you can just say select all. Give it a size. I'm just giving it a size of, let's say, 0.5. Measure, I'm selecting hybrid measure and I'm naming it as MT, suggesting for main tunnel. Say apply. So the meshing has proceeded. So we'll mesh it, the 20 solids for our main tunnel. Fine. So the meshing is done. Similarly, let us mesh the side tunnel. So we can say select all. So the 8 objects is selected. Just ST so that I can differentiate it from the main tunnel and say OK. Apply. Fine. The meshing is done, and if you say the program takes care of the nodal connectivity, okay, no issue from that point of. Okay, so once you do the auto connect, the program takes care of nodal connectivity, and finally you have the main tunnel. So I'm just saying select 2 mesh size, and I can give it a name as main ground. I'm sorry, not main tunnel. So main ground, and just say OK. So this is how the meshing will be done. First we start with the area of concern. We mesh the main tunnel and the side tunnel, and then you can give a bigger size to your main ground. And just if you have taken care of auto connect with the solids, and the solids are in proper connection, of course, the program takes care of the nodal connectivity. Okay, so I will show you one check which will help you ensure that the meshing is good enough, or the nodal connectivity between the main tunnels and the ground, or the side tunnels and the ground, has been taken care of. Okay, so that check, which we call it as check free faces. So the basic idea is there shouldn't be any free face inside the model. Okay, the free face should always at the outer ends or at the boundary of your model, for example of our main ground in this case, and you shouldn't see any free face inside the boundary. Okay, or so this will be giving you a clear idea that your meshing is correct, and you can proceed on with the next part. Just to show you the check till then, it will take some time to analyze, especially with the hybrid measure. So till now we have meshed it. Okay, the next step, even if you remember from first session 1, the thing which we need to take care for the construction stage definition is the naming. Okay, even if you are going to use the construction stage wizard, or if you are going to do it manually, I will show you both the aspects today. So even if you want to do the manual activation deactivation, so you should be able to make sure that whatever you are deactivating is the correct named uh, or correct named mesh set, because if for example if it's not properly named, the issue will come with the construction stage definition. You might be thinking that I am deactivating excavation 1, but you might be deactivating excavation 7, and you are activating the reinforcement for shotcrete 1. So as a result of that, it can lead to numerical instability, and at times create a lot of confusion that even for such a stable soil, how exactly we are not able to converge the model. Okay, so one should take care of that. Now, so how to take care of that? So till now the geometric part is done, except when we'll use it to extract our shell. Now let us see the mesh sets. So these are our mesh sets. I'm just hiding the main ground. Now see how exactly the program names this. So MT1 is the third excavation, MT2 is second excavation. So to avoid confusion, so let us rename it. First of all, I'm hiding all the side tunnels. So mesh, there is an option in mesh set rename. Select the object, so select all, everything hidden other than the main tunnel. First axis is Y, this is the axis it will be using to name it or rename it, and then you say as empty EX. Okay, so whatever comfortable name you can give it to, so that you can understand what is empty. For me here stands for main tunnel, and excavation is the excavation mesh. Okay, so you say apply. Okay, so I'm just shorting it by name so that I can show you that it's a name correct, excavation 1, 2, 3 and so on. Fine. Similarly, I will hide this mesh sheet now and I will activate the side tunnels, select the object, say select all. Now this time it's x-axis, right? And we are doing the excavation in the positive. So I'm naming it as STEX1 and till 8. Okay, once again I'm just shorting it by name. So you can see excavation 1, 2, 3 and so on. So hiding the other mesh sheets. Now the next thing which we need to do is we need to extract the shotcrete. Now it's very easier with the geometric face. So even you can use the mesh sheet, I will show you, but I always prefer using the geometric faces for easy selection. Okay, so you go to mesh, in the element you have an option called extract. Okay, please note that this function only works even with geometry when you have already meshed the model. So it takes that meshing and ensures the nodal connectivity between the two solids. Say select face, say select all. Now when you say select all, it has selected all faces which is shared in between the solid. So we need to uncheck it. So unselect it. So unselect mode is on. So this is the selection filter. At times select all, unselect all, select by intersection, this is select mode and unselect mode. This is the basic selection filter. This part is very much important whenever it comes to selection. Okay, so I have selected the unselect mode and I go by select by intersection, go to the front view. Then I click in between the solid so that I can uncheck everything which is inside the solid. Then I'm going by unselect by single, unselect mode is on, and I'm unchecking this part, okay, because I don't want any shotcrete as of now here because I will be extruding it in the other direction. Okay, then registered based on owner shape. Owner shape is 20 solid, so it will be naming or extracting based on that solid. Very important for me when I'm doing shotcreting in stages. Okay, so I'm naming it as shotcrete. Just now I can write empty, anyways I will rename it again. So okay, if I hide the main tunnel solids, so this is how my shotcrete looks like with stages. Okay, so there are 20 shotcretes. Okay, now similarly let us do it for the side tunnel. So I'm using the face command again. So extract face. Okay, so there is option of using mesh only, but selection wise I find it easier to deal with geometry. So face, select all. So 49 is selected and the unselect mode is still on. So I'm going to this view, a little bit zooming, so you can zoom if you move your scroll up and down. Then select by intersection. Fine. I'm crossing it from both sides because what happens many a times, since this is a curve face, sorry, if I go to this view, this is a curve face, it sometimes remains unselected. So you can rotate the model. To rotate the model, see, everything is by here, rotate, pan, zoom in, zoom out, but you can always use mouse to zoom in, zoom out, and if you press the scroll of your mouse, you can rotate the model with the speed, and if you press control on keyboard and press the scroll, you can move it laterally like a pan. Okay, so all the commands can be done using mouse as well. Fine. So let us once again name it registered on owner shape and shotcrete ST. Fine. Say okay. Naming is done. Fine. If I hide the side tunnel solid, so these are my shotcrete. Fine. Now let us rename it so we can properly use it in our construction stage definition. Say rename. So once again select all, direction is x-axis, side tunnel shotcrete. So it will start from 1, say okay. So pretty confident that the naming is correct because now we have selected the correct direction. Similarly for the main tunnel. So rename, say select all, say Y direction, and empty standing for main tunnel, and shortcrete, and just say OK. Fine. So the naming is done, and this is our complete meshed model. Fine. Now we'll move on to the next tab we call static slope analysis. So first of all, we need to define the boundary condition to our model. You go to constraint. So you have the basic, and basically where you have the terminology as fixed, pin, rotation, no rotation. Advanced, where you can manually check the degree of freedom, be tx, dy, tz, rx, ry, rz. Or auto, especially auto is more efficient with whenever you define the ground support. So you just select it, give it a name, and just say OK. The program will provide the boundary condition to your model. Fine. So please remember that till meshing everything was in model. So analysis, for example, I want to hide my boundary set, I can go there and hide it from there. Fine. Then the self weight, say SW. So just you need to activate it and just say OK. Fine. So this is done. Now this is the basically complete modeling. If you say we started with the geometric modeling, we defined the material, defined the property, meshed it, then extracted the mesh, defined the boundary condition, and finally the loads. Okay, so only self-weight for us in this case. Now let us go to the construction stage definition. I will be showing you both the options to make you understand how exactly the stage definition wizard works. Please note that try first using the manual definition before you go to the construction stage definition. Okay. So stage set, I just name it as manual. Okay. For few stages, I will be showing it to you. Say add, define construction stage. This window will be opening, and I'm moving the model on my right hand side so that I can simultaneously see how my definition looks like. Okay. As you know, for any geotechnical model, the first stage should always be in situ. Okay. Whatever there is present exactly in the ground. Okay. All soil condition, basically no construction till now. So in situ, so we have all the excavation soil. Now you can say activate. Okay. So whatever you activate goes into the analysis, and you can simultaneously see what you have activated. Fine. So main tunnel, so you have 20 mesh sets activated. Then no shortcrete in the first stage. Then you have the side tunnels, and finally you have the main ground. Okay, so these are all activated. Then ground support condition, I have kept hidden from here, but it's activated, and self weight. Fine. Now clear the displacement. What it means that first stage we don't want to see any displacement because of the load which you are activating. Okay, or whatever you are activating, we only want to consider the stress analysis. Okay, suppose even there is a situation where how can this be used in more other options? For example, if we have a building, okay, it's been there for 20 years, so we want to check the change in the model stress condition, change in the stress condition of the model due to the building. But since the settlement has already taken place, you don't want to see what is the settlement coming due to the building load. So you can say clear the displacement even in the next stage. Okay, so this is the use of this function. So save it, say new. Fine. Now what I can do is I'm just hiding main ground. Please know that it's activated, but just to show you inside the model. Okay, first stage is main tunnel excavation 1. Okay, and I'm naming it as like this, excavation 1. So excavation 1 means you are removing something, so you'll take that, it's already activated in the first stage, so no need to activate it again. You just say deactivated data in the column of D, so you can see it's removed. You say save, then you say new, then you move on to the next, say empty excavation 2, and shortcrete 1 will be activated in this stage, let's suppose. Okay, so it moves there, and then you activate shortcrete 1. Please remember that till now we have not touched any shortcrete, so you can see the importance of naming. You see that empty shortcut one, you just drag and drop and you can see that it's activated. Fine. Similarly, you have to define it for all the stages. Clear? So it's a tedious process when you do it manually, but at times there might not be a regular pattern of using the stage definition widget. So I just made you clear that how exactly the manual option can be used. Okay. So close it. Stage definition wizard. So please remember that for stage definition wizard, the mesh set should be properly named. Okay. Otherwise, you cannot activate and deactivate it easily. And I'm just saying stage definition, and I'm adding a different construction stage. Okay. Close it. So let's suppose stage definition. Fine. So first we need to define the pattern. Please note that in situ is a different stage. So basically the number starts from S1. In situ we anyways have to consider. So mesh set. First, if you think we have material empty, main tunnel excavation. So what we are going to do, addition or removal. Start postfix we have named it properly, so it will start from 1. Okay, and end postfix you have 20. Fine. So postfix increment, so 1, 2, 3, it will go one by one. Start stage is 1, we'll start from here, and stage increment is 1. Okay, with each stage we'll be moving 1 by 1, 2, 3 like that. Then mesh set 2. Now let us talk about the main empty shortcut addition, of course, and then it has been also started from 1 to 20. Increment will be 1, but the initial or the start stage is 2. Okay, and then the stage increment is 1. Once again, mesh set, you have the excavation. Now we have 1 to 20 occupied by main tunnel excavation. So we'll be removing, of course, deactivating it, and it starts from 1 to 8. Okay, so you can see from the workspace window as well, starts from 1 to 8. So end is 8, and I'm taking the stage as 21, the start stage. Similarly, for shortcut for the side tunnels addition, and this is also 8, 1, and this I'm taking 22. So one step. Fine. Apply assignment rules. So automatically it came. Now for the in situ, we need to activate whatever we are into. Main tunnel is of course, main ground, main tunnel excavation set, and shortcut excavation set, ground support, and finally you have sulfate. Okay, everything is done, and just say OK. Fine. Now just to make sure we have defined correct, I'm deleting the manual one. Say define construction stage. So this is the definition which has been defined. Just we need to clear the displacement for the first set, save it, and we can see that the definition goes till 30 stages. Now let us simulate it. It will be good for us if we can see. So I'm hiding the main ground again, so that because it's already activated in first stage. If I play it, so let me just slow it down a bit. So this is how it looks like. If you can see that the mesh is removed and shortcut activated one state default, then we come to the side tunnel, and finally we complete the construction stage as we desired. Clear? Finally, after you define, you just go to analysis, you go to general, select the solution type as construction stage, give it name CS, good enough. Here you need to do initial stage for stress analysis. Please remember we have cleared the displacement. This is the second important thing which you need to take care. Just say OK. And finally you can perform the analysis. Okay. So just perform and just say OK. So I've already analyzed one model so that I can save some time and show you the post-processing results. Fine. So once you analyze the model, once you analyze the model, you will go to the post-processing mode. Okay, this is the mode. So here in the results, with each stage you can see all the results. So displacement, grid forces, reactions, solid stresses, solid strains. Fine. Now let us just have a complete look on the main ground. So simultaneously I will show you what are the various options to look into the model results. So let's go to the last stage so that we can see the complete TZ or the displacement contours. Okay, so this, first of all, please note, take care that these are the various control options. I will just first make it undeformed. Okay, and let's say total translation. What is the displacement basically? So this is how the model looks like. Okay, the first thing which comes to mind is we want to see inside the model, right? So you can cut it. These are the two. These are first three options which I will like all of you guys to have a look at. So clip, you can just cut it in between. Okay, fine. So similarly, if you see, the clipping plane has an option of even changing the axis. So this is X, if you make it Y, and I just will just reverse it. So for the side tunnels as well, how exactly the total translation is taking place. Okay, so clipping plane, one option. Fine. Now, many might of you might be familiar with the vector thing, which gives you an idea basically. Okay, so this is the vector diagram. Okay, now the control properties, like if you want to increase the size of arrows and everything, can be controlled from properties. If you see in the workstation window, so you have contour, vector, so you can just increase the size and everything from here. Okay, so I'm going by default right now. Fine. So this is the vector diagram, non-vector. So smooth, basically whether you want to see, many of the software gives like this, and few are interested in the fringe so that they can delocate the area. And then edge type, basically type of view. Many times you want to see the elements as well, so that while probing it becomes fill, solid fill, or line. Okay, and no results, how basically these are all basically the view properties. One thing which will be important here is ISO value surface. Okay, now let's suppose you are interested in TZ. Okay, so this will give you an idea basically which are the areas having a displacement more than this. Okay, so if you just move it, so you will get an idea. So there is a lower part, so these are the area which are having a settlement in we can say, if I change it to millimeter. Okay, so in millimeters you can just check what is the value basically. Fine. So like if you want to check what is the area having a settlement more than 1 millimeter in the model, so you can see like that, even if you can say no edge, so that you can directly see it like that. Fine. So this gives you an idea basically of the area. Then of course we know about probe. Any point you are interested in, you can say probe. So any particular stage you can use it. Fine. Then you have multi-step ISO. Okay. So what happens is, for example, now I'm talking of all the stages. Okay. So if you want to see the displacement contour, now once again this is very much as as what I just show now, ISO value surface. So these are the surface which are having equal settlement or a settlement more than this particular value. Okay, now it is showing for all the stages. You can hide various stages. For example, if you're just interested in last stage, fine. So this is how the last stage settlement profile will look like when you move for different values. Fine. Next is cutting line diagram. Okay, now you have two things. Cutting line, for example, if you want to see the top surface settlement profile, I'm just making it in the top Z direction. Say okay. So if I say TZ, so you can see that what is the settlement profile. Okay, so you can make use of this line at various intervals. Fine. Now there is one more option which we call as cutting plane. Okay, now this will be very much helpful as discussed in session 1. For example, I'm hiding everything. Just let's say the short grids. Okay, making it undeformed. Good enough. Fine. And let's say we go by edge. Fine. So you need to define 3 points. Okay. I'm going to top view to do a proper selection. So first and same plane. Okay. If I say preview, so you can see the bending moment diagram for that particular face. Okay, so you can control once again the length so that you can get diagram. Okay, so membrane force diagram, the membrane force XX, XY, all can be directly taken with the help of the cutting diagram. Okay, good enough. Then you have now a very big problem comes is that when we say TZ. Okay, now let's just hide this cutting line diagram, and I'm just switching on everything. Fine. Now, when we clip it, okay, what happens is, let us make it no edge. What happens is at times you want to probe. What is the value here? Okay, but you cannot probe it because you don't know whether exactly there is a node or not, because you know that you can only probe at nodes. Okay, so MIDAS GTS NX has an option of 3D to 2D wizard. So when you do that, the program will automatically show you node locations, okay, where you can now go and probe. Just a second, I will have you look at it. Say if I want to probe, I'm just pinning it down. So 3D to 2D wizard. So now you can probe at this nodes to check the value. So that will give you an idea that how exact, what is the value actually being there. Okay. Now if I say probe, so you can use that nodes to probe. Okay. So even now you can just go and click at any point. Just a second. Let me just add this plane because every time I'm doing this it's closing. So let's say add, say 3D 2D wizard. So you can click at any point here. This is how you can add those plane, because every time I was clicking as clean, so you can check the value at that particular point. Okay, so this 3D to 2D wizards helps, it takes basically the average values and gives you a node so that you can probe the values down there. Fine. So these are few of the features, few important features. For example, taking a screenshot, right? Now there are 30 stages and I want to see the displacement TZ for all the stages. You just say, for example, consider all steps. Okay. So, and just say execute. So the program will automatically take screenshots for all the stages. Just a second, it's taking for only 2 steps. Say displacement TZ, yeah. Okay, so all the stage and say execute. So it's continuously taking all the values, all the screenshots. Okay, now I have just taken the half cross section to take the image for especially for the main tunnel. It will be very much useful for me, right? So I will just show you what basically will be the outcome. Fine, so this is the folder basically. So it gives you the screenshot for each of the value. Okay, it is previously, so it will just take screenshot. Okay, and it will give you the value for with the probed value for each of the stages. So very easy to take the values out in a screenshot. Otherwise, you have to just take screenshot and all. Okay. Finally, if you go to tools, we have one option called flight simulation. Okay. I'm just hiding and just going to the main view. Okay, flight simulation is basically you can define a guide curve. Okay, let's suppose, let's see, I already have defined one curve basically. Let me just hide it. Okay, for example, I define this guide curve. Just say select it, just say reversing the direction going from the main tunnel to the side tunnel. Okay, and let's suppose we want to see what is the situation when it's TZ. Okay, and I'm just slowing it down a bit. So this is a control and just say play. So it will give you a flight simulation of the movement inside the tunnel, okay, so that you can have a look. So it's just for presentation that how exactly it looks when you are moving right through the tunnel. Okay, so that's all from my side. I think I tried to cover most of the things from the basic geometric modeling, how to define the material property, meshing, different post-processing tools which you can use it while you deal with, especially with tunnel problems. Okay, so that's all for today. Thank you very much for attending the session. Hope to see you all again in the next session, where we'll be talking mostly about what's the advantage of 3D analysis, why we need a 3D analysis when we can do a simple 2D analysis to design or to get the moments in our short grid. Okay, so thank you very much to all of you again for taking out time for this session. That's all from my side. Have a great day. Thank you.